there, and what's showing up there is a bit delayed. So if you feel comfortable, you can advance your screen a bit before you actually start talking to the next. I don't know how comfortable you feel with that. So anyways, I will track the questions and I'll pose them to you as we go through. So you have about 40 minutes.
But you do an intro first,
right? If you feel comfortable, you can advance your screen a bit before you actually start talking. There's a delay because I have the two screens. It's recording the one that's there. I will get used to this at some point. So they'll be starting to come on, and I'll let you know as we go. Okay. Yeah, so I'm at the host. Okay. So we'll give it, I still think I'm waiting for it to come in live. I'm just wait. It's really for those sessions that are just ending. Right now, they're joining this one, so I'm just going to see as get the viewers are just coming in now. So, yeah. And here they all come. So, just give me 2 secs here. Okay, so we're going to kick off. We're still in stream 2, and now we're in the next session. So welcome to Transforming Information Sciences. I just want to let everybody know that so that you know, this is about a 50-minute session, 40-minute presentation, 10 minutes Q&A. Post your Q&A throughout, and you're able to vote. People in the audience can vote and say, you know, here's what that really interests me. We want to make sure we get an answer. Everything is recorded. You will be sent a link, and you will get a copies of the deck. And everything is left on CVent for 90 days before it moves to YouTube, and the presentation will be made available in PDF format as well. So not to worry, you will receive some copies today. So I would like to introduce Dr. Louise Spiteri. She's a professor at the School of Information Management at Dalhousie University in Halifax, where she also serves as the chair of the Dalhousie Senate. Her research interests span from social tagging and folk synonymies. This is the first time I've heard that term, so excuse me if I bumped over that. Linked data, the contribution of user-generated metadata to library catalogs, reader advisory services, knowledge-based, knowledge organization systems, and enterprise use of social media and online zero-waste communities. So today she's going to be talking to us about exploring the extent to which information science education continues to meet the needs of these changing environments and provide more learning opportunities for new and experienced information management professionals. So Louise, I pass it over to you. Welcome, and thank you so much for joining us today.
Thank you very much, and thank you for the invitation. I'm doing this from home. I must apologize in advance if my phone goes off. I'm expecting courier delivery, and I am leaving the province tomorrow, so I may have to put myself on mute for just a second. So I do apologize. It's very unfortunate timing. So thank you. So today we're going to talk about in transforming information science education. And there's a slight delay with moving the slides. So let me just check to make sure. There we go. So information science is the science and practice of dealing with the effective collection, storage, retrieval, and use of information. And its primary focus has been on recordable information, or what often we call published information, some form of fashion, and the technologies that we use to facilitate the management and use of that recorded information. And it also looks at how we communicate information and information objects, particularly knowledge records amongst humans in the context of social, organizational, and individual need for this information. So it's very much concerned with how human beings create, transmit, share human knowledge in the form of recorded form, centering and focusing on the manipulation and the organization and retrieval of information. And that's the pretty standard definition of information science. Now, typical information science education is, in North America at least, but also in Australia and the UK, is offered by programs that are accredited by the American Library Association. And these programs typically educate students for professional positions in a variety of information-intensive organizations. And we tell them that the GLAM industries, we often refer to them, which is galleries, libraries, archives, and museums, also government agencies, corporations, and not-for-profit. So it's a very broad spectrum of places. This slide shows the typical core courses that you would find in in Canadian and American ALA accredited programs. Again, the number of core courses will vary from program to program, but you have an idea here of the types of organizations. So it's quite a mixed group of core courses, and all of them are pretty much focused upon, as we mentioned, how one manages or transmits or communicates information that is in a recorded form. And again, these tend to be, in Canada, they are graduate level programs. So they're at the master's level. There are some bachelor programs in the US, but that's not very common in Canada. So while most of these ALA accredited programs offer information science programs or IS programs geared to the broader discipline of information management in a variety of settings, there is a growing shift to adding concentrations or even new programs that are focused on data science. And we'll talk more about that in a minute. So data science has become a real area of growth for information science education. And these schools are playing an increasingly important role in promoting data science across many disciplines. So let's look a little bit more closely what we mean when we say data science, because again, like most concepts, there are different interpretations of meaning. So data science is an emerging interdisciplinary field that concerns identifying and extracting valuable patterns from big data, converting data into information and knowledge through data analysis and data mining. Now, we'll be talking later on about the synergies between information science, education, and data science, because there are areas of overlap and areas of significant difference. So data science, the term data scientist was coined in about 2008 when companies realized that increasingly they needed data professionals who are skilled in organizing and analyzing massive amounts of data. And these skills are required in almost all industries, including government. And you see in the job ads, for example, the number of the data scientist positions are actually growing almost exponentially from year to year. And in the past decade, data scientists have become increasingly necessary assets and are present in many organizations. They have a rather interesting set of skills. They are very data-driven. They have to have high-level technical skills and are capable of building complex quantitative algorithms to organize and synthesize large amounts of information used to answer questions and to drive strategy in their organization. This is coupled with the experience in communication and leadership needed to deliver these results to various stakeholders in a way that makes sense, because part of what they do is translate the data and the findings, because the data tends to be very quantitative, and that's not always the most user-friendly way of communicating that information. Now, these are some of the competencies that data scientists are required to have. So they need to have very strong background in statistics. They have very strong mathematical skills. So we've mentioned linear algebra, programming, mathematics. They also need to have, and this is the interesting mix, they also need to be very good storytellers, because besides having the technical mathematical skills and the programming skills, they need to have the analytical skills to be able to deal with a lot of quantitative data and crunch a lot of numbers. But they also need to synthesize results, communicate those results to key stakeholders in a way that is understandable and user-friendly. So the types of programming skills like Python, mathematical skills, storytelling, data visualization, use of tools such as Hadoop, SQL, machine learning, it's a very mixed bag of skills. Now, here's a typical example, and I'm not going to go over each one of these things, but it's what the typical data science life cycle looks like. And it does tend to be, although this is a square picture, it is actually quite cyclical. And all of these areas are areas where data scientists are involved in to a variety of means. And I've provided you that with the link that explains this diagram in a little bit more detail. So one of the things that we are looking at, sorry, I'm working with 2 computers and 3 screens, so I apologize, my eyes are darting in different places. So what is driving the shift in information science education? So over the past few years, there's been a real change in how companies or organizations are capturing, storing, and disseminating information throughout the organization. And it's driven very much by the exponential growth in the amount of data that organizations generate. And a lot of this data is unstructured data. So it's a combination. Structured data tends to be numerical data that resides in databases. Unstructured data, which is a larger proportion, would be things such as text documents, video recordings, audio recordings, closed caption TV, all of that will be unstructured data. And the amount of structured and unstructured data is growing at almost an alarming rate. And the big challenge, one of the many big challenges, is that very often in many organizations, this information exists in many different places. So it's siloed data repositories. So different types of data are stored in different units in an organization, and those units often don't talk to each other, they're not connected. You also have, and I know certainly at Dalhousie, we have a lot of these siloed data repositories where we're trying to work towards integrating, but it's a very long and difficult process. You also have increasingly AI, artificial intelligence enabled information management functions. And increasingly, we're using artificial intelligence to help us manage this data, find the data, and also, for example, a simple application is to separate information which contains personal information, because that comes under different privacy requirements, different legal holding requirements, from information that does not contain personal information. So you have AI can do this automatically. You also have increasingly artificial intelligence being used in a search process. And we're not talking the simple Google one box search. And many organizations rely upon this, but increasingly it's a very ineffective and inefficient way of managing your search. This is really what AI does. It is studies patterns of search behavior to the point where it can actually almost predict what it is that you want to find. And that's often based upon an analysis of previous searches in a particular area. It can actually provide you a prompt you into search results without you even necessarily have to do a great deal of input, because it automatically, once you start the searching process, based upon its algorithms, it can predict what kind of information resources you will actually need. AI is being used as well to help classify data. And I'm a metadata specialist, this is what I do. And creating good metadata is a very arduous process. It's very time consuming. And artificial intelligence is being used increasingly to help manage metadata and create metadata on a very, very large scale. And without good metadata, you run the risk of actually losing information. You can't retrieve it, you can't find it effectively, particularly if it's discoverable under law and you have to find information without good metadata, you run the risk of actually not finding what you need. You also have increasingly growing amount of automatic analysis of quantitative data. So a lot of the data analysis applications can be automated, but the IT managers have to be always very conscious of developments in new technologies, new possibilities. So for example, you've got statistical and modeling tools such as Spotify and Target are used quite extensively in organizations. And this is becoming increasingly important because big data is being used so much to monitor customer behavior and to analyze how customers use their sites, and they adjust the merchandise, the periods of a website, number of other factors based upon this automated analysis. Data visualization is a growing importance in the area of data analysis because humans are very good of interpreting and deciphering images. But when it comes to reading spreadsheets and reports, particularly very quantitative, they can be much harder to interpret unless one has a strong mathematical statistical background. So it's becoming increasingly important now to present data in a visual method to make it more understandable and digestible to humans. And this allows you to manipulate large data sets and present them in a visual way, which are easier to understand, and also can be integrated and manipulated in three-dimensional spaces as well. You have areas such as small data and tiny ML. Again, these are all various things going on right now, but essentially what happens with this is it allows you, because some of the data sets are massive, and you've got, for example, you have a system called GPT-3, which can, it has about 175 billion parameters. And what it does is it's particularly useful at modeling human language. But a lot of these data sets are extremely large, and many organizations don't have the bandwidth to handle that all at once. So what you can do is we have the emergence of what is called small data, which allows you to, sorry, my cat's decided to visit if you're hearing weird sounds in the background. So what this does, it allows you to do analysis on only subsets of the data at a time. And that allows you to be more efficient in how you manipulate your data. And the tiny ML, which is tiny machine learning, again, these are decided to be machine learning in a compressed space, again, for organizations that don't have the bandwidth to handle, billions of bits of data at a time. You have auto ML, which is automatic machine learning. This is a really interesting thing because machine learning requires a lot of human input because you have to train the system. Auto ML can actually help an organization to generate automatic machine learning without the need of very highly skilled IT managers. Again, this is relatively new technology, so it's still in development. There's the deep fakes. I don't know if any of you remembered, I think last year there were the deep fakes of Tom Cruise that had all these TikToks of Tom Cruise doing all of these things, including discussing a meeting held with Gorbachev. It turned out it was not actually Tom Cruise. And if you've seen things like in The Irishman, Robert De Niro was de-aged to look a lot younger. It's kind of creepy looking when you look at it, but they're actually doing everything they can to make the person look younger. So this is the deep fakes, and there's a concern for deep fakes, of course, because you could end up, in fact, there's a huge potential there for fraud. And also we're talking about, this is the synthetic data. So synthetic data is used as well to create synthetic faces of people to train computers to do facial recognition algorithms. So they're not actual people, they are synthetically designed. And again, something like the film industry has been doing this for a long time. The anywhere, anytime access to information, we have seen this certainly with the pandemic, where increasingly people expect to have connection to their work environment anywhere that they are. So again, that this causes a lot of complexity with regards to data security and privacy. Big data analytics, we've already talked about. Smart technology, increasingly, we have smart devices. I'm wearing 3 of them right now, and they are all generating huge amounts of metadata and personal information. And also, of course, the growth of the Internet of Things. So connected computers that will, as you say, you do this now, if you're shopping somewhere, you can be beeped, because stores are actually tied to your phone, your GPS, so they can actually flash you. We have a code. We notice you're in the shopping mall. This store has a code for 20%. Come in. So again, that's an enormous amount of data that's being generated. Some other things, areas of IT that we need to consider is obviously cybersecurity, because as we have increasing amounts of data, that means we are increasingly more vulnerable to data breaches, and the data breaches are on the rise in many areas. We have predictive and analytics. This is also the idea, and this is being used a great deal in market analysis, where you can predict consumer behavior. You have increasingly, we are working in a connected world, so you need to have systems that allow you to create collaborative work environments. And I'm sorry, I think I just shifted something by mistake. Sorry about that. An extremely sensitive mouse. Zero trust security is becoming increasingly important, where security is taken to an extreme end. And we're talking not just, network security authentication. We're also talking about very, very robust auditing trails, login auditing, because so the zero security follows the entire life cycle of information from beginning to distribution. Every step of the way, there's security gap stops throughout the entire process. Clearly, consumer data protection is of increasing importance. This is an area where Europe has been doing a great deal of work. I think Canada is, I don't think, at the same level of data protection, but we certainly have improved over the past few years. But certainly the Cambridge Analytica scandal really highlighted the importance, and people are becoming more and more aware of the fact that there is a great deal of information being collected about them, and that it's very, very prone to data breaches. So that also means that information management professionals have to be increasingly aware of legislation that governs data protection, and that is jurisdictionally bound. So depending if you're in Canada and you're dealing with the United States, you have to be aware of your data privacy legislation, their data legislation. If you're dealing with the European Union, you have to be compliant with their standards. So there's a great deal of policy involvement there. Cloud computing, of course, is something that continues to increase in usage. And mobile apps as well and mobile apps are on the rise. And I know now, I see many of my students, for example, and they kind of laugh. They say that, laptops are old technology. I mean, they barely even use, tablets used to be very popular. They're not anymore because smartphones have pretty much taken over. So increasingly, we have smart systems. For example, I work exclusively in the cloud. So I use a Chromebook because I don't store anything. So the ability for mobile apps are growing enormously in importance. And then you also have edge computing, which again, this is where you are processing large volumes of data towards the edge of a network, and that is to optimize the speed. So again, the idea is you're finding more efficient ways of handling very, very large data sets. So these are all the various challenges and opportunities that IS education is dealing with. So the next slide will show you the response of academic programs in North America towards this new paradigm of data science. So here's an example of, these are different. Some of them are actual full degrees, other are concentrations. And I put them as a metadata person in alphabetical order because that's just the way my brain functions. So we see a lot of these topics very much touch on the various aspects I've just talked about of what data science is concerned with. So again, the degree to which these programs are offered varies, but I have noticed there's been a real uptake in these courses over the past 5 years and even less. Here's an example of course titles that we are seeing in IS programs. Again, very much tied to the problems we've talked about before. And they will come to various degrees. And again, this is a selection across, I looked at various programs across Canada and North America, and these are the types of typical titles that you would see. These are not exhaustive lists, by the way, there are more courses. And again, this is more, again, I've done them in alphabetical order, so to show you again, very much. And some of them are rather interesting. For example, this political violence, insurgency, and terrorism is a very interesting topic. This is in the United States in particular, because there's an increasing understanding of how data and big data are being used for promoting or supporting acts of political violence and insurgency. I'm not making a judgment call here, but it's very much tied to how it can be used. And also the idea is how one responds to that and what security measures one needs to have in place. So what we talk about really is how how information science and data science, how we're trying to blend these two complementary but different fields. So again, data science is very much taking raw, messy data and transforming it into some actionable knowledge which supports decision making. Information science has a similar approach. They are more concerned really about how one organizes and utilizes knowledge. There is an overlap. They have slightly different scopes. So data scientists are very much concerned about the analysis and the visualization of information, the interpretation, running the programming and the statistical analysis. Information scientists have a broader approach, and they focus upon how people organize, create information, how we organize information, how do we interpret the information, how do we store it, how information seeking behavior, how people search, how do people share information. So information sciences really look at kind of the entire life cycle of information from beginning to creation, organization, storage, retrieval, and use. And information scientists are very much concerned upon the human aspect, is how do humans interact with information? How do we search for information? What are the ethical uses of information? These are not covered to the same extent in data science. So one of the things that we want to look at information science education is how we can combine the elements of data science with information science. So we're at a very interesting stage right now because a lot of information science programs, and our program at Dalhousie is one of them, is increasingly incorporating data science courses into our IS programs. The potential challenge with that is that the skill sets required for data science are rather different from the skill sets that traditionally IS programs have asked students to come with. So information data scientists tend to have a much stronger background in mathematics, programming, computer science, whereas information science students, when we recruit them, tend to have a much broader perspective, not for any one discipline. So the challenge is, do data science courses embedded within an IS program provide sufficient exposure to data science? So that's a question that we are dealing with at the moment. So this can have an impact upon recruitment to these programs. Also, the challenge with data science education is that it's very focused on the technical skill sets, as we've listed. But it may not cover areas that information science has done very well, which is things such as data literacy, people's ability to actually understand and interpret information when they use it. Ethics, what are the ethical uses? And in the world of big data, that is an increasingly important question because there is a great deal of potential to misuse information. We need to think about information governance. What are the policies by which we govern how information is used? That is something which is more traditional in information science. Data science may not be dealing with that to the same extent. Information behavior, information needs. So the interesting questions to be asked is that data science it's very data focused. And the concern there, and various experts have been talking about this, is that the data science approach is very positivist. It tends to view data as this kind of objective, you crunch the numbers and outcome the results, where you are perhaps not considering the societal and cultural environments in which information exists and where it's interpreted. And there's also the notion of, again, ethical use of information. There's a whole justice aspect, social justice involved in this. So ideally, what you really need to have, I think, is a hybrid where you have the aspects of information science married with the data science. And this is, I think, where many of our programs are at right now. It's an exciting place to be because these kinds of changes are actually, I find them really exciting because obviously we are changing a great deal. So there are opportunities there. So what I wanted to look at briefly is for those of you who are immersed or you're already in the profession, information management professions, what continuing education options are available to you. I would be remiss in not mentioning one of our programs because after all, I work at Dalhousie, of course, but there are several programs across Canada offer part-time options for mid-career professionals. We have at the Dalhousie, this one example, we have a Master of Information Management, and you can do it in stages. So you can get a certificate, diploma, or master's degree, and it's blended. It's mostly online with face-to-face, and there's certainly more information. That is, by the way, our building, the Kenneth Zero Management Building. So there are opportunities to take certificates from a variety of IIS programs, which can have a data science component and specialization. So that's something you might want to think about. Another area that is really exciting is the area of micro-credentialing. This is has been around longer in the United States. Canada we are catching up. And micro-credentialing is it's a process of earning a micro credential. So these are what are known as mini degrees or certifications in a specific topic area. So to earn a micro credential, you have to take a certain number of activities, assessments, or projects related to this topic. And the number will vary depending on the area. And then once you've completed those requirements, you submit your work and then you earn the credential. So micro-credentialing is a way to recognize competencies or skills acquired through a variety of learning experiences. So it's not necessarily the traditional university model. Although they are offered by universities, the assessment is a little different. It's much more granular because you're much more focused on a very specific topic. And you have also, there's a lot of flexibility. You can mix and match the different micro-credentials based upon your needs, whereas in a traditional program, there's less flexibility in doing that. And then what you do is you earn digital badges. And they're actually, these badges have embedded within them information about everything that you did. It's kind of like a digital transcript. And this can also be combined with a portfolio to show what you've done. So the digital badges can actually be done if you're going to a job search or you're looking for a promotion. You can actually show the digital badge and include a portfolio of the courses that you've taken. A really useful resource is Ontario, Government of Ontario has an extremely good, now it's showing up, I'm sorry, it's blue on blue, but there's the URL there, it's microlearnontario.ca. And it actually lists all the micro-credentials that are offered in the province of Ontario. And I've just given, I've listed a sample of micro-credentialing courses that you can take. And these are primarily online. And I've chosen micro-credentials that are related to the area of data science, because that's what we're talking about here. So you can tell a lot of those topics are exactly the areas that we've been looking at in IS programs. And you can take as many of these. And again, when you go into these via this website, it'll give you more information about the types of topics that you can do. And they vary. So for example, you've got Toronto has, York and Toronto have a very large selection of courses that you can take. And for example, the ones from Toronto are, there's healthcare analytics, which is an area of huge growth, and machine learning in business, for example. So these are really good opportunities as well to explore, to help you keep up to date with data science, get some skills that would help you continue to meet the needs of your organization, because I think that's increasingly important. And I know Dalhousie, our Faculty of Open and Continuing Education has micro-credentialing. And I know in our program, we are also considering it in faculty management, because this is an area of growth and it provides a really flexible opportunity to continue their continuing education in a way that's not as structured perhaps as going through a full master's program. So thank you very much. Here's my my contact. I've got my Twitter, and I have Counter Social, which is the Twitter, the non-Elon Musk version of Twitter, or Elon Musk to come version of Twitter, and also the website for the school and my About Me, which gives a list of my publications. So I am 4 minutes early. I hope Jennifer does not mind too much, but I have my timer on. I have 4 minutes to go. So thank you very much. And I will stop at this point.
Oh, no problem at all. Thank you very much for that overview. I think it really provide with a good breadth of how the academia is evolving in terms of evolving their programming to support the needs around information science and data analytics. So we'll ask people to post questions if you have any questions. Something that I had was like, what I'm seeing more and more is like a separation between data and information, right?
Yes.
And I was there before, but in the federal government, what I really have noticed is that you have the CIOs and the role that they play, and now a rise of the CDOs, so the chief data officers. And I'm just wondering what do you think of that trend, and whether you think it's something that should continue or something that really needs to be better integrated?
I think, and that's a very good question. I think, again, in my area, there's the whole notion of the difference between data and information, and then there's knowledge and wisdom. It can get rather messy. I think the reason we're seeing the increasingly, I think, the division between data and information, mostly, I think, because of the increasing growth in data. And again, depending on how you interpret it, data is often, you could think of it as being the data is just the raw data. Information can often be data that's being interpreted to mean something, right? So it's given. So for example, if you have information about me, data about me is simply things such as, my gender identity, my height, my weight, my date of birth. On their own, they have no meaning, but interpreting them and including things like a biography about me, that becomes more information. I think that the concern that I have about that is separating them, and this is why we talk about more information governance, is that information is based upon data. That division becomes very difficult. And I think that the concern about, just thinking of data on its own is that you may be not considering the ethical questions and the use, the privacy, the way that this data can be manipulated in a way that can cause harm. So I think, and you need a little more integration. And I think also, again, my concern about the data being a separate silo, if you will, is that it's very tech focused, but what may be lacking is the interpretation of that. So I think increasingly we need to have more integration of the two rather than a separation of the two. But I do understand what's driving the trend, and it's essentially, it's just, I think it's the sheer amount that the data is creating.
Okay, perfect. Yeah, that's one of the challenges that I keep thinking about. What would you advise to young persons? I thought you had a lot of really good connections and links and identification of programs that are there for people who are mid-career and looking to either raise their skills and competencies in these areas, or wanting to pursue more work in this area. What about young people who are pursuing sort of data analytics? What area would you suggest they go in? And just to let you know, I have like 3 kids in university. And
Okay.
I keep pushing from a government perspective is like everybody's looking for big data.
Absolutely.
Analytics. Everybody needs people who can do this. So I'm just wondering if you'd see any like really emerging or leading edge programs in those areas that are sort of capturing that. I know many are evolving, but just wondering what your thinking is on that.
I think honestly, this is, I looked at the figures the other day, and I forget what I saw, but it was a list of the number of job postings over the past 2 years, and the data scientist is the largest growing, apparently, position right now in North America. So it's increasingly huge amounts. With data science, very often, I use Dalhousie as an example of this, is that very often they're run via computer science programs. And at Dalhousie, for example, we have a bit of a hybrid model because we've got computer science. We also have our business school, because a lot of this is very business driven. So we've got the management information systems involved. We have our program involved because of the management perspective. To be honest, I think this is an area where it may not be a good idea to have data science education rooted in only one faculty or one program, because having that cross-disciplinary approach is extremely important. So, for example, if you look at an IS program such as ours, the computer science program could provide incredibly important programming and kind of the data analytics. That's areas they do very strongly. Where we would come in is more the human behavior, the human data literacy, information literacy. And we had a presentation about 3 years ago, and a data scientist who came from an IS program, and that's exactly what he was saying. He said, it's not just, the challenge he finds is that in a lot of the data science programs, the emphasis is very much upon the computer skills, the programming skills, and analytical skills, and those are important, but having those hybrids. So I think right now, I think that doing these via the IS programs is the best way to go about it, because traditionally information science has reached many different disciplines. And certainly University of Toronto, for example, is doing strong work in this area. I think McGill is also very strong in this area, and York is getting there. But it's still an area of growth. So it takes a while to have established programs, because we're literally, the environment is changing yearly, and academic programs can't change overnight. There is, I can tell from Chair of Senate, there are processes one has to go through, and it can't happen overnight. So I think at this point, keeping an eye, if you go to a program, just to see how data focused they are, and if they're not including things such as the human aspect, the ethics aspect, they need to rethink their choices, or maybe take courses in programs that give them that lens of the social justice and the ethics and the governance perspective and the policy perspective, because none of this is going to work if you don't have a strong information governance. And that's in our MIM program. Our emphasis is very much upon information governance, because that underlies everything that we do.
Perfect. Yeah, there is a bit of a lag for sure. So I have a question: statistics versus mathematics. In data science, there are two majors that are considered in data science, these two majors are considered interchangeable, or which one is considered more critical than the other one? That's sort of one. And what's the difference among data engineers, data scientists, and data analysts?
So data engineers, again, you've got, again, and one person can have all three skills. So that could be something kind of interesting. So I think the engineers look more about how the information is processed, the technical aspects of how you control it, you manage it, and you process it. You've got sorry, what was the other ones? The other two, sorry. The engineer, what was the other?
Sorry. It was the data engineers, data scientists, right, and data analysts.
Right. So data scientists is a very broad term, and very often the data scientist of the three has kind of the umbrella skills of all of them, depending on how granular your skills are and what your organization needs. So for example, the data analysts will do just that. Their job is to crunch the data and make it work. It often will depend. So the data engineers may have a stronger programming background. The data analysts may have a stronger statistical background and research background. Data scientist is often, if you will, kind of a bridge between the two, because a good data scientist also has the ability to do things such as data visualization and interpretation of the data. So again, when you look at the skills of all three, they often have a lot of commonalities. It may often be a question of way. So for example, I'm a metadata specialist, so I can also, however, design metadata. I can design thesauri, I can design taxonomies, the various things. I can also do knowledge management. So it's the level of granularity. The difference between stats and mathematics, they're very similar. The difference is essentially a mathematician is not necessarily a statistician, right? So you need to have an understanding of what statistical tests to run, what are appropriate, what would be valid, and interpreting the data. So you need to have both. But I think for data science, the statistical component is probably going to be a little more important, because you have to be able to and make sure that you are running statistically valid tests for whatever your query happens to be.
Mm-hmm. Okay, perfect. And now we have one on the retention and disposition of information, regardless of format or media, is a central component of information management. Is this a similar requirement, or is it understood by data scientists?
I would argue probably not understood as well as it should be. And again, this is where I think the information science aspect is a very important contribution. Because, for example, one of the areas I teach records management. So we're all about retention and everything else. So I think that where the information science aspect comes into play, I think, and that helps balance, is understanding that information has a life cycle, and you retain information, and sometimes there are legal requirements for how long you keep information. I think the danger potentially with not having that lens is keeping far more information than you should, particularly that information has personal information, because you can store it, you can keep it. And if a data scientist is concerned with how we can manipulate this data, that's great. But there are also legal requirements for retaining information and for not keeping information forever in some cases. There's very strict limits as to that. And to be honest, when you look at a lot of the data science courses, they're not looking at things like retention. They're not looking at that. That's not the main focus. And I think that's a bit problematic, because you could in fact end up hanging on to information for far longer than you should, and that increases the amount of potential for breaches. So I think, again, this is another area where having an extremely strong information governance infrastructure, which is the strength of information science, comes into play, because that has to cover all of that aspect of ethics and retention and preservation.
Perfect. Well, thank you for that. I think we've pretty well reached the end. We're just about time for a break. So Louise, I'd really like to thank you for taking the time today to share with us and provide what are the opportunities that are out there and the emerging opportunities for new and experienced information management professionals in terms of accessing this. So I found it very helpful. I'm sure everyone else did as well. So thank you. I hope you enjoy the rest of the conference. We now go to break until 2:30. Yep, 2:30. And we'll be back. And there's 2 more breakout sessions before the end of the day and the wrap up. So thank you for your time today. We appreciate it.
Thanks very much.
Okay. Have a great day.
You too. Thank you.
Bye.